Hello everybody and welcome to another exciting episode of Radiorama, where I show you how to work primarily on radios. And today we have this cute little butterscotch colored Emerson portable. It's an AC or DC set. And we take for granted how small and compact electronics are. And the reason I say that is because this is not light by itself. And this guy, if you were to buy the batteries for it, you'd have to buy two. There was one battery, an A battery, which was about 4.5 volts, and then a second battery, which is 90 volts. And the reason that they had these two different batteries is because one of them was a cheaper battery that was only made for powering the filaments in the tubes. And then the B battery was a longer lasting battery that provided the juice for the B+. If you look here, there's probably a place to plug the plug in. Here it is. And that flips a switch and that turns this tube and probably this resistor off. Because this is a 117 volt tube. It's just basically serving as a big fat ballast. When this is battery powered, this tube and probably that resistor are taken out of circuit. And then we go immediately to using these four 1 to 3 volt filament tubes. Let's see, what are the tubes anyway? We have, here we go, here's the list. 3V4 for the output, 1U5, 1U4, and 1R5 for the IF and RF stages. There is more than likely a selenium rectifier in this thing because hardly any of these portables came with a rectifier tube per se. Let's see, what do we have here? I remember when I looked at the values on the side of the can, which is the electrolytic here, that one of them was 80 microfarad, the other one's 30 microfarad, and then a 300 microfarad cap, but only at 15 volts, so it could be quite small. Condition-wise, it actually still works. Now, to what extent is this set original? We're going to find out when I take it out of the case. Anyway, I'm not sure how much of this I'll get done today. I got a call from one of my friends he's got some sort of potential health issue, and so I'm kind of worried about him. And unfortunately, that's just kind of what happens when most of your friends are older. I'm in my 40s, and most of my friends are 65, 75 and up. And so I experience a little more frequency of having friends either get sick or in some cases dying, and it's always really upsetting. But if you're watching, you know who you are. Hope that you're going to get to feeling better. All right, hang in there, buddy. All right, so let's take the chassis out and remove the bottom cover to the chassis and see what's going on inside. All right, well, here is the chassis. And I can say with some level of confidence that it's all original. No one's really ever been in here before, which is kind of remarkable if you think about it. As with most portables, there is a lot of capacitors. These ugly, sticky, orangish things, those are the old paper film caps, and all of those need to be replaced. And we have a total of, let's see, 4 here, 8 paper caps, and then of course we have the 3 electrolytic caps that are inside this black can here. We can tell it's a floating chassis because the lugs for the capacitor are going through this phenolic spacer, which is good. That's what we want. It's less of a shock hazard. And because I'm electrically ignorant, this doesn't have a solid state rectifier. The rectifier is actually the 117Z3. I'm curious about that. Because if it was battery powered, like how in the hell would you power that filament and have a battery last for any length of time? I'm not sure if it has more than one section. Maybe it's got a low voltage section. I don't know. 117. So the thing is that someone can correct me on this. Probably it doesn't have more than one section, because 117 that indicates how much voltage it takes to light the filament. That's how at least American tubes work. If you see a 1, a 3, a 6, or a 12 in the front part of the tube of the type, that is the amount of voltage it takes to light its filament. So I'm not really sure how that works. I could, quit being lazy and pull up the schematic to have a better understanding about it. Or I could just say the hell with it. Whatever it does, it must work, because it did work, and get down to the business of replacing these individual electrolytic capacitors. We have a hump, a square, and a triangle, and each one of those represents the different values. If my camera would focus instead of getting all hazy. The hump is the biggest value, our 80 microfarad cap, and if you look behind these lugs, they should have a shape. It's hard to film this, but that's a triangle. There's one that's not marked. That is our high microfarad low voltage cap. Let me peel this back here. That is the square. I guess actually, maybe I'm wrong here. All of these have a shape. Okay, yeah, that's the square is the 30 microfarad. What was that triangle? Triangle must be the 300. All right, so here's 30, 300, and by default the other one is 30 microfarads. No big deal. So we'll replace all three of these sections in that electrolytic can. So I'll quit flopping over with 3 individual electrolytics. This is a, what is this rated? 330 at 25 volts. Fine. Your electrolytics can go at or over to an extent. You don't want to go crazy with going over the capacitance level, but at least it has to be at least above or greater as far as capacitance and voltage. The other two will just be replaced by one of these guys, which is a 47 microfarad cap, and the 80 microfarad cap will be replaced by this. This is my last one, 100 microfarad cap. So there we go, all three. I'm going to find something to lean this up on so it doesn't keep on falling over. And while I'm at it, I'll replace all the caps that go around here to clear up some room for the electrolytics. Alright, so I've replaced all the electrolytics and the associated caps that were near there, and usually I don't put electrolytics underneath tube sockets, but since these are just like 1-volt tubes, they're not going to get warm. It's fine. So let's go ahead and plug it back in, and hopefully it still works. So here goes nothing. Now, of course, since the rectifier tube's this 117 volt thing, it probably doesn't turn on immediately like most portable tube radios do. Wouldn't it be dandy if it just didn't work? That'd just be my luck.
With a 2.425 have suggested a million weaker. But because of a...
Holy crap, it's sensitive. Well, to be fair, these radios were sensitive. They had to be because they were portable, and instead of sitting stationary on a tabletop somewhere, they had to be designed for extra sensitivity since they were getting swung about out in the picnic grounds or whatever. Now, the next cap I'm going to look for, which is very important, is the grounding cap, meaning to chassis ground. And it's this guy, because you can tell, because it goes from this connection to chassis ground. Hence, the under end of the AC line goes through that cap. Its value is way too big. It's probably like 0.05 or something. Let's see. Yep. 0.05 microfarads. And we need to replace that guy with the safety cap. And they look like a whip. Jesus, what that just knocked down. It's like quite a bit of a thud there. Oh well, anyway, it's an X2Y2 rated across the line cap, and that will replace that guy. Otherwise, we just have a whole crap ton of nasty little wax caps that need to be replaced. And there goes my neighbor that has a squeaky serpentine belt on his car. Every morning he starts that car up at 6:30 a.m. and it squeals and squeals like crazy. And I'm tempted to go over there and be like, maybe you could replace that belt. It's squeaking. But I won't, because that'd be rude. Alright, so we got it recapped here. Some of these were rather difficult to get at, but I was able to get them all replaced.
It's that time again. Harry's is an award-winning breaking injuries. They led up to
Guards tried to check on the purse and pop.
Pretty happy little radio. Even with replacing the cross the line cap or the grounding cap, still very clean. Usually I lose a little bit. I get a little too much AC hum coming in, but it's working just fine here. So now what I'm going to do is clean the volume pot, which is this suckaroo right here. And just spray some stuff into the unplug it so I can work it back and forth. Really? John Irwin was a legend in my neighborhood. He helped preserve the history of our region. That's really sad. I used to go there and watch a lot of music concerts. Yeah, he'll be missed. All right, anyway, I'm going to clean the cabinet and the sink, and then I'm going to get out the old plastic polish because I believe I've done all the electrical work I want to do for this evening. And the rest of it is just need to clean up this filthy cabinet and get out the good old-fashioned Novus number 2 plastic polish. Welcome to day 2 of working on the little bitty Emerson portable. Actually, it's more like day 3. I got kind of distracted yesterday. Someone dropped off this television. It's a 60s era Packard Bell. And I haven't worked on televisions in a while, so I was quite excited. But I'm not sure if I'm going to be able to do much with it because I've got a bad flyback transformer, meaning I have no high voltage going to the CRT. And flyback transformers are wildly different from one another. You just can't plop another one in it. So that's aggravating. But let's get back to the thing I was supposed to really be working on, which is this chassis. Now, the last thing I'm going to do is add my oh-so-famous, oh-so-popular audio input, which some people who are quote-unquote purists disdain. But it kind of gives the set this whole new life by being able to not only play radio, as it was intended, but to run an audio signal through the set's existing amp section. And how we do that is we're going to run a signal through this isolation transformer. And you want to mount it as close as you can to the volume pot, which is this guy. And there's not a lot of room in here, but I think I could probably stick it there. Yeah, that should be fine. Let me take a look at this. Does that go innie or outie? I think it goes out. So I can mount it absolutely flush to this top here and nothing will interfere with it. And what we're going to do is we're going to run the primary side of the isolation to the outer legs of the volume pot. And then we will run the audio signal via a audio cable into the secondary side. There's a little more stuff we have to do beyond that. We need to split the we need to tie the two right and left channels together through a pair of resistors, and then also run a 0.02 microfarad cap and a resistor that's approximately half the value of the pot's resistance, which is about 270K, and that will preserve the set's automatic gain control feature, because otherwise this transformer can kind of get in the way of that and cause the set to shriek a little bit. And then lastly, we'll need to install a switch that takes the IF signal, basically the radio signal temporarily out of service until the user decides they want to listen to the radio again. Now, before I get too carried away, I'm going to do a test. This is essentially a safety check to make sure that we don't have any naughty current left on the chassis that would be harmful, which we shouldn't, because the only thing going to ground is this cap. Now, there is a lead coming off of one of the tubes, the center pin here. That's probably just a shielding ground. Probably not necessary for the set to work, but sometimes that can mess up your readings. So I'm going to go ahead and do a safety test, and then I will proceed with the audio input feature. Okay, so you want to make sure and have the set fully warmed up when you do this test. I've got a little probe here. That's running my line out. Calibrated output is 250 millivolts AC. We have a reversing switch. So on the neutralized side of the chassis, we're getting 0.008. On the 2 volt range of my multimeter, I'm looking for a 1/6 of a volt maximum. I've even written it down here so I don't forget. All right, 0.33. So that is essentially a little over half of our way to our max. So this is well within that safety threshold. Hence, the audio input feature can proceed. All right, so the audio system, input system installed. Here is the right and left channels going to 2 resistors. And then that goes to the primary side, which has a 270K resistor and a 0.02 cap. And that goes to the top side of the pot. We've disconnected the IF signal, and now I have audio running through this. Whoops, someone just sent me a text. Anyway, it's working pretty good, so I'll need to install a little switch wire. I'll just have it come out this hole. And I've also glued in and knotted the cord so that it's not going to chafe. No one can yank it out of there. I'm probably going to cover this guy up with a little bit of hot glue. This keeps everything nice and sealed up. And so now it's time to reassemble and reinstall it in the case. Alrighty, she's all done now, and I think it turned out pretty good, actually. Initially, I was like, this is kind of a gross color, but after I polished it up last night, it actually came out quite nice. So I've got my Bluetooth running through it.
On the wedding yonder round the bend, rivers upon you're gonna be flowing, big sweet flowers are gonna be growing, when I'm back in my baby's arms again.
I've certainly heard worse radios. I mean, this is kind of nice because it's little. It'd be a good little shelf model for someone to have in their kitchen or something like that. And like I said, it cleaned up pretty well. Anyhow, that is the end of this episode of Radiorama. And we certainly fixed another radio. Like I said, I really wished that I could have torn that thing. I'm hankering to get that damn thing fixed if I can find a flyback transformer. But in the meantime, if you guys enjoyed watching this episode, make sure and press that like button down below. Make sure and ask any questions that you might have, and I'll try to answer them the best I can. And until the next time a radio or possibly a television comes across my workbench, see you guys next time. Adios.